Hi, Year 9, and welcome to Thursday's lesson this week, which is reaction rates and concentration. So today we're going to look at how concentration affects the rate of reaction. So if something's more concentrated or less concentrated, how does that affect rate of reaction? And also we're going to look at how pressure on the rate of reaction affects how fast or slow the reaction happens. Looking at concentration of solutions and also the rate of reaction due to pressures. So to start with, it's a flashback to yesterday's lesson. Can you put those four animals and insects in order of surface area to volume ratio, smallest to largest? Go. Okay, hopefully you managed to do that. Let's look at the answers. These are the answers. The elephant has the smallest surface area to volume ratio, and that little insect there, I believe is a flea, has the largest surface area to volume ratio. So the smaller an animal gets, the greater the surface area to volume ratio is. So what does concentration mean? And what do you relate to that word? So pause the video now and can you write down for me what do you think the term concentrated means? And then what do you relate to that word? What type of general day-to-day things do you talk about when you talk about concentration or concentrated? Okay, so hopefully you've paused the video and managed to come up with a definition of what the term concentrated means. If you didn't, what do you relate to that word as well? Well, this is the answer. So concentration is the relative amount of a given substance contained within a solution or in a particular volume of space. So it's the amount of solute per unit volume of solution. So think about it in terms of squash. If you like quite a weak squash, you won't put much squash in, but you'll put lots of water in. But if you like a strong squash, a high concentration of squash, you'll put lots of squash in the glass with not as much water. So it means that there'll be more squash particles to water particles in a high concentration of squash than if, for example, you had a low concentration of squash, where there'd be less squash particles. So can you please have a go for me? Can you try and write out that definition of concentration in terms a 12-year-old would understand? So someone in year 7, can you try and write a definition that would make them understand what the word concentration means? Okay, hopefully you've managed to do that. So as you can see from this diagram here on the screen and what you're about to see in a minute during the live experiment is that we've got a conical flask and we've got this gas syringe attached to the conical flask. So the gas syringe is going to collect the gas produced here in the conical flask. So we're going to be using hydrochloric acid and changing the concentration, so 0.5 and 1 mole concentration. But instead of manganese dioxide, we're actually just going to use marble chips or calcium carbonate, and they release carbon dioxide in a reaction with hydrochloric acid. So we're going to use the same amount of hydrochloric acid as a control variable. We're going to use the same amount of marble chips as a control variable, but we are going to change the concentration of the acid 0.5 and then 1 mole. And then we're going to record the amount of gas produced every half a minute for 5 minutes. Okay, and so this little syringe will start moving outwards as the marble chips react with the hydrochloric acid.
Hi, Year 9. Today I'm going to show you how concentration affects rates of reaction. Right, so before I start carrying on with my practical, I'm just going to briefly show you the different types of equipment that I'm going to use this in this practical. So firstly, I'm going to use this conical flask. If you look at this conical flask, there's a tube attached to a gas syringe. So I'll be starting to collect some gas in this gas syringe. I'll show you in a minute how to use that. And then I'll also be using some small marble chips in my experiment and two different types of hydrochloric concentration. So over here, I have hydrochloric concentration of 0.1 molar and hydrochloric concentration of 0.5 molar. Stopwatch and measuring cylinder to measure the concentration of the hydrochloric acid in my measuring cylinder. Right, I also have my paper and pen so that I can record down all my information on that. Right, so firstly, what I'm going to do is I'm going to measure my hydrochloric acid solution first. So I'm going to use the lowest strength, which is 0.5 molar first. So I'm going to measure around 25 centimeter cubic. Right, to be very precise, I'm going to leave it on the table and I'm going to squat down and check if I've got the correct accurate measurement of my hydrochloric acid. Then I'm going to pour that into my conical flask. Then I'm going to put few lumps of small marble chips, just about 3 to maybe about 10. Then I'm going to quickly close that with my stopper. Right, so what is happening over here is, if you can see, there's lots of reaction taking place. You can see the marble chip is gradually reacting with hydrochloric acid. Okay, right, so at the same time, then, right, so you can have a clear observation of this. So what's happening over here, the reaction is taking place where the small marble chips of hydrochloric acid is reacting with hydrochloric acid. Okay, so what's happening over here is the chemical reaction will start to release CO2 inside this gas syringe. Right, so I'm going to start my stopwatch. So for every 10 seconds, I'm going to measure, I'm going to look at the measurement of CO2 in my gas syringe. If you see, the plunger will gradually move backward. So from there, I can work out the volume of my CO2. Right, I'm going to stop that.
Hi, Year 9. So I hope you enjoyed that live demonstration of an experiment. Now, these two links here, I'd like you to type them in and follow these links. They will show you another 2 ways that this experiment is done. So follow this link, please, and write down for me or copy down some information on what their results are and how these experiments are done. So you need to watch both of these videos. Just copy the, write them down and then type them into a search bar and watch these 2 videos for me. Right, so the last part of the lesson I want you to do today for me is write a conclusion. So how does the concentration affect the rate of reaction? Must use the word particles, energy, and collisions in your responses. So things to think about, what one would have reacted fastest, which one would have been slowest. Don't worry about data, obviously, for this one. I just want you to get your key ideas down. So there's some keywords down there. And then also try and tell me why one reacted the fastest and one reacted the slowest. So what's the pattern? What were your findings? Obviously, you can't back it with evidence currently because we don't have evidence for this experiment, but then link it to what you know. Okay, so write down a conclusion for me. So pause this video now and write down your conclusion. Okay, hope you've paused the video and written down a conclusion as best as you can. Here are some answers for you. So the higher concentration acid has more molecules of hydrochloric acid than the lower concentration acid. So the 1 mole has more acid particles than the 0.5 mole, which means that there are more molecules of hydrochloric acid that can collide with the molecules of the calcium carbonate, those marble chips, which means that there's going to be more collisions. So the collisions are going to be more frequent, and therefore there's more chance for collisions to have the minimum activation energy, which means that the rate of reaction is going to be greater. So if you didn't get that answer, pause the video again and just correct your answer, please. Hope you've enjoyed this lesson. Okay, remember, on Friday, we'll be kind of quizzing you and making sure that you remember all these. So make sure you're keeping your notes with you. Obviously, again, you don't need to email your notes to Miss Callis or myself. You just need to have your notes in front of you for Friday's lesson with us and then on Sam Learning. As always, stay safe and take care. So overall idea right there.